Imagine this, companies like Nvidia, AMD, Apple, Qualcomm, Intel, Samsung, and MediaTek spend millions of dollars designing a single chip. But after writing the RTL code, can they directly send it for manufacturing? Absolutely not. Between RTL and the final silicon chip, there's an entire engineering domain responsible for transforming that logical design into real manufacturable chip. That domain is called physical design, and the professional behind it are known as physical design engineer. Today's physical design has become one of the most exciting and in-demand career in the semiconductor industry. With the rapid growth of artificial intelligence, autonomous vehicle, 5G, high performance computing, and advanced consumer electronics, companies are constantly looking for skilled physical design engineer. But many students still have a question like, what exactly does a physical design engineer do? Is this role more hardware oriented or coding oriented? What skills are required to enter this field? How much salary can a physical design engineer earns in India? Is the market really growing? And most importantly, is this the right career choice for you? If you have any of these questions, then you are in the right place. In this video, I will explain everything in a simple and practical way, from what physical design is to the responsibilities of physical design engineer, the skill you need, salary, market opportunities, and the company hiring in India. So without wasting any more time, let's first understand what exactly is a physical design. Now, before understanding what a physical design engineer does, let's first understand what physical design actually means. Imagine you have designed your dream house. You have the complete blueprint showcasing every room. But can you start living in that house just because you have the blueprint? Of course not. Someone still has to construct the actual building by placing every brick, laying electrical wiring, plumbing, and making sure everything works together. The same ideas apply in chip design. During the RTL design phase, engineers describe what the chip should do using hardware description language like Verilog, system Verilog. But RTL doesn't define how the chip will be physically built on a silicon. That's where physical design comes in. Physical design is the process of converting a synthesized digital circuit into a physical layout that can actually be manufactured in a semiconductor plant. In simple words, a physical design engineer transforms a logical design into a real silicon chip. But this is more than simply placing block. The engineer decide where different parts of the chip should be placed, how they should be connected, how power and clock signals should be distributed, and ensure the design meet all timing requirements. Even a small mistake can affect the chip speed, increase power consumption, or even make it impossible to manufacture. That's why every physical design engineer constantly balances three key objectives. First is performance. The chip should run at the required speed. Second is power. It should consume as little power as possible. And the third is area. It should use minimum silicon area to reduce manufacturing cost. These three factors, known as PPA, performance, power, and area, are the heart of physical design. Now that we know what physical design is, let's understand why it's such an important stage in the semiconductor industry. Now that we know what physical design is, the next question is why it is so important. If the RTL is already written and functionally verified, why can't we directly manufacture the chip? The answer is simple. A functionally correct design doesn't automatically become a manufacturable chip. Think of it like a cake recipe. The recipe may be perfect, but unless someone actually bakes the cake, you can't eat it. Similarly, RTL describes what the chip should do, while physical design ensures the chip can actually be manufactured and perform reliably in the real world. A physical design engineer makes sure the chip is fast, power efficient, compact, and manufacturable. Take your smartphone as an example. You expect app to open instantly, games to run smoothly, and the battery to last all day. If the physical design isn't optimized, the chip may run slower, consume more power, generate more heat, or even fails to meet its performance target. That's why physical design focuses on achieving the best balance between performance, power, and area while also satisfying strict manufacturing rules. In fact, even a small improvement in chip area or power consumption can save semiconductor companies millions of dollars when manufacturing chip at a large scale. So, physical design is not just another step in the SIC design flow. It's the stage that transforms a logical design into reliable, high-performance product. Now that we understand what physical design is and why it's important, let's talk about what a physical design engineer actually does. In simple words, the responsibility of a physical design engineer is to convert a synthesized design into a manufacturable chip while meeting all the design requirements. But this is not just one person task. A physical design engineer works closely with the RTL designer, DV engineer, DFT engineer, and ST engineer to ensure the final chip performs exactly as expected. Their day-to-day work involves multiple stages of physical design flow, such as floor planning, placement, clock tree synthesis, routing, and timing optimization. At every stage, they continuously optimize the design to achieve the best balance between performance, power, and area, also known as PPA. Along with implementation, they analyze timing reports, fix setup and hold violation, reduce congestion, optimize power consumption, and ensure the design satisfies all manufacturing rules before tape out. In short, physical design engineer is responsible for delivering a chip that is fast, power efficient, reliable, and ready for manufacturing. So, if you enjoy solving engineering challenges, analyzing complex design, and optimizing systems, this role can be both exciting and rewarding. But to become a physical design engineer, having the right skill set is equally important. So let's discuss the skill you need to enter this domain. Now the next question is, what skills do you need to become a physical design engineer? The good news is that you don't need to know everything on a day one, but having a strong fundamental will make your learning journey much easier. First of all, you should have a good understanding of digital electronics because every chip is built using digital logic. Along with that, having basic knowledge of CMOS technology and the ASIC design flow will help you understand how a chip is designed from RTL to fabrication. Since physical design is all about meeting timing requirement, you should also be familiar with static timing analysis and basic timing concept like setup time, hold time, clock skew, and clock latency. On the software side, learning Linux and TCL scripting is very useful because most EDA tools are used in Linux environment and many tasks are automated using TCL script. You should also become familiar with industry standard EDA tools like Cadence Innovus or Synopsys ICC2. Don't worry if you don't have access to this tool right now. Companies understand fresher may not have hands-on experience, but they do expect your fundamental to be strong. Finally, one skill that often get overlooked is problem solving. Physical design is all about analyzing report, debugging issues, and optimizing design. So having a logical and analytical mindset is just as important as technical knowledge. If you build this fundamental step by step, you will be well prepared to start your career in physical design. Now, let's talk about one of the biggest reasons many students are interested in this field. How much does a physical design engineer earn in India? If you are joining as a fresher, the salary can vary depending on the company and your skill level. Generally, fresher can expect a package around 4 LPA to 10 LPA. In a service-based companies, the starting package is usually on the lower side, while product-based companies like Qualcomm, Nvidia, AMD, Intel, Apple, Samsung, or Texas Instrument can offer significantly higher package to candidates with strong fundamentals. After gaining around 2 to 5 years of experience, salaries typically range between 10 LPA to 20 LPA, especially if you have worked on a multiple tap-out project and have expertise in timing, closure, routing, and sign-off. For engineers with 5 years of experience, compensation can go well beyond 20 LPA, and experienced professionals in top semiconductor companies may earn 30 LPA, 40 LPA, or even more, depending on their role and expertise. However, remember that experience alone doesn't guarantee a high salary. In the semiconductor industry, companies pay for skill and impact. Engineers who can solve complex timing issues, optimize design efficiently, and contribute to successful chip tape out are always in high demand. So, if your goal is simply to get a job, you may earn an average salary. But if your goal is to become a highly skilled, your salary growth can be exceptional. Now that we have discussed salary, let's see what the current market scenario looks like and whether physical design is still a good career choice. The answer is yes, and the demand is expected to continue growing. Today, almost every major technology company is designing custom chip for application like AI, smartphone, automotive electronics, data centers, 5G, and IoT. As more chips are being designed, the demand for skilled physical design engineer is also increasing. In India, the semiconductor ecosystem is expanding rapidly. Many global companies such as Qualcomm, Nvidia, AMD, Intel, Cadence, MediaTek, Texas Instrument have established or expanded their design center here, creating more opportunities for VLSI engineers. At the same time, the government focus on semiconductor manufacturing and chip design is opening up even more career opportunities in this domain. However, there are one important things to understand. The demand is high, but so are the expectations. Companies are looking for engineers with strong fundamental and practical knowledge, not just certificate. If you invest time in learning the right concept and keep improving your skills, physical design can offer a stable and rewarding long-term career. So yes, this is definitely one of the most promising domain in VLSI, provided you are willing to keep learning and growing. Before ending this video, I would like to share a few pieces of advice with every student and fresher who want to build a career in physical design. First, don't choose this field just because someone told you the salary is high. Choose it because you are genuinely interested in solving engineering problem. The salary will come as your skill grow. Second, focus on building strong fundamental instead of collecting certificates. Many students complete multiple courses but struggle to explain basic concepts during interviews. Companies hire engineers who understand the fundamentals, not those who have the most certificate. And third, don't compare your journey with others. You may see someone getting placed in a top companies quickly, while someone else take a year to get their first opportunities. That's completely normal. In this industry, consistency matters much more than the speed. And finally, be patient. VLSI is not a field where you become an expert in a few months. It takes time to understand the concept, develop problem-solving skills, and gain confidence. But once you build the foundation, you will have a career that is both challenging and rewarding. So keep learning, keep practicing, and most importantly, don't give up after a few rejections. Every interview teaches you something new and bring you one step closer to your goal. I hope this video gave you clear understanding of the physical design engineer role. If it helped you, make sure to like the video, share it with your friends, and subscribe to Logic Verify because we will continue learning VLSI together. Thank you for watching and I will see you in the next video. This is Logic Verify signing off.